So in this video, we'll be looking at sequences. For explicit formulas, we are going to find the whatever number of terms of the sequence. And it will usually look like this. They will usually tell like this. And then you're going to have to find the values of an from n equal to 1 to infinity. So we are going to list the first 5 terms of the sequence. And what I mean by that is we are basically going to plug in 1, 2, 3, 4, 5 into n. So it's like a sequence basically. So let's start off with putting 1. So n. So n would be equal to 1. So this would be 1. And we can do that for whatever number of terms. So let's say we're going to look for the first 3 terms. So with the first 3 terms, we would just put it like that. So this would be a1, this would be a2, and this would be a3. And this is the answer if they're going to ask you for finding the sequence for the first 3 terms. It could be 5 terms, it could be 6 terms, but just know that you're going to plug in the terms needed for a sequence. So let's move on to recurrence relations. So a recurrence relations is basically that we are given the same thing, an, but we have to, in this case, we will add 1, and we're going to find the sequence for the recurrence relation. So let me just give you all an example. So basically we have more numbers to plug in, but it's the same thing as before. So here we're given a1 equals 1 and a0 equals 1. So we're going to start off with a1 plus 1 because we're going to start off with a1 because a1 plus 1, that will be equal to a2. So we are trying to find a2. See, so basically this is there, and this is a1. This is a1 minus 1. This would be 1 minus 1 is a0. So, and we have a1 and a0, so that fits perfectly into this problem. So this would be a1 would be 1. This would be 1. A2 equals 2. So we have that. And we're going to find the first 3 terms again. And so let's put in a2 because we already found out. And we don't forget the plus 1. So this will be like that. A2 minus 1, that would be a1, and we have a2 already because we solved it in the previous step, and we have a1 just from our problem. So a2 is 2, and a1 is still 1, so a3 is going to be 3. And since we have our sequences, all our sequences for the first three terms, we're just going to plug it in here. It can be more, like they may ask you to do 5 or 6 terms, but this is just a basic example of what it will look like. And finally, we have limits of sequences. So we're basically using AN again, but in a different way. So let's say they have like this problem. So basically, if we have a number that is less than infinity, then that will be convergent. If we have a number, if we have no number, and if that's infinity, that will be divergent. So make sure to remember that when you're doing the limits of sequences. And when we do limits of sequences, we are going to do this simple method. So here we have the problem, and for our first step, we are going to rename this question into n to the power of 3 to over n to the power of 3 plus 1, and make it equal to an, because that is going to be important. Next step is, do the limits. We have to do a limit every time we are trying to find convergent or divergent. So, yeah, and make sure put n to infinity. And you have to do this to all of the limits if you have to do it. And so this would be equivalent to this. And we have to just do this little simple trick. We have to basically divide the highest numerator, the highest exponent factor from the denominator. So in this case, the highest exponent in the denominator is n to the power of 3. So we're going to divide all the numbers or values, and we have to divide it by n to the power of 3. So it would just look like this. And when you see this, n to the power of 3 will be just 1. N to the power of 3 over n to the power of 3 will be 1. And this would be equal to 1 as well. And 1 over n to the power of 3, that will be equal to 0, because the number is infinite, and when you divide over an infinite number, that is just 0. So this will be equal to 1. And from our sheet right here, we can see that the number is less than infinity. So that means this sequence is convergent. So you're going to have to write it like this. So this is convergent. First of all, we have to rewrite this into an, so just do this, rewriting it. We can do the same thing as before. So how can we do this? So we can take the square root and let the limit go inside. So that would be much more easier to do. We can do this. The highest exponent is just n, so we are going to divide by n for each one. So this would be equal to square root of 1 over 9. And the square root of 1 over 9, we can just do that individually. So the square root of 1 is going to be 1. The square root of 9 is 3, so it's going to be 1 over 3. And 1 over 3 is less than infinity, so this is convergent. Alright, so this problem is different because this is a natural log problem. So if we're trying to find the sequence of this, we're basically going to use the same thing like as every problem, but we're going to use L'Hopital's rule. And this is pretty much just doing derivatives. It's nothing crazy. So we're going to, just rewrite this to an. We have 2 at the exponent, so we could bring that 2 over here. And we have to derive from the inside, so that would be 1 over n. And we have to derive from the bottom, that would be just 1. We can have it like this. And now we have to derive it again, or use L'Hopital's rule again, because it's necessary for this problem. So this will be just 1 over n, just be 1. So this will be 2 over n, 1 over 1. So it will be 2 over n. When we do this, and now our next step is just dividing it by 0 at this point. So, or dividing it by the n, or the highest exponent. So we have to divide it. So 2 over n and n over n. So this would be equal to 0. N over n will be equal to 1. 0 divided by 1 is just 0. 0 is less than infinity, so this still works. So the problem is still convergent.